Hello guys, welcome in this new video. In this video we will be discussing about insertion sort, and it is actually a similar algorithm like the selection sort one, but with a small difference. And if you haven't checked the previous video where I discussed about selection sort and bubble sort, then please do check it out as it will be helpful to you. And with no further delay, let's get to the insertion sort algorithm. So insertion sort is also a simple sorting algorithm, and it works similar to the way we actually sort the playing cards while we play the card game. So in this also, like the selection sort, we actually split the array into the sorted and also the unsorted part, and we pick the values from the unsorted part and place at the correct position in the sorted part. Okay, so it in this you can actually see the pseudocode as like this, that first of all we iterate over all the elements, and one by one we check with the predecessor of the current element, which is the key. And if key is smaller than the predecessor, then we compare it to the elements before and move the greater elements one position up to the to make space for the swapped element. So let me explain you this algorithm. So let's say we have this array, and we start with the first index. So as first index has no predecessor element, so we go to the next index, and as 3 has the like first index as its predecessor, so we will compare them. And if the current key element, that is 3, is less than the predecessor, then we move third to the first position and actually shift 4 to the right position. So basically what we are doing here is actually rotating the array into clockwise direction. So again, after this we go to the next index. So we compare 2 with 4, and as it is lesser than 4, then we compare with the predecessor of the predecessor, so that is 3. And as it is also less than 2, so we will try to compare with the very pre-predecessor. But as 3 has no predecessor, so we will actually set the second element to the first position and shift all the elements right side. So 4 will come in place of 2, 3 will come in place of 4, and 2 will go in place of 3. So we rotate it. Similarly, we check for 10, as 10 has 4 as a predecessor, but it is greater than 4. So we will just move to the next element. So 12 also is greater than its predecessor. So we go to next element. Similarly, we check with the when we come to 1, then we will check with 12, it is less, so we will check with 10, it is also less. So we will check with 4, it is again less, then with 3, then with 2. At last we will put 1 to the 2's position and actually shift them all the elements to right one by one. Okay, now again checking for the fifth. Now one interesting part comes here. So when we check with 5 with 12, so it is lesser. Then we check with 10, it is lesser. But when we check with 4, so it is greater than 4. So whenever this case happens, we then put 5 in that place and shift other elements that were greater than 5 to the right side. So 12 will come at the place of 5, then 10 will come at the place of 12, and 5 will come at the place of 10. Okay, similarly we do with the sixth element. And now, as there is no other index left to go ahead, so the elements which are left are now in sorted order. Okay, so you can watch its another example here as well if you like, but it's the same as what I told you. Now coming to the code, so this is the main algorithm. Yeah, this is the main algorithm which we are actually implementing in the code. So in this we have two loops. So one is the for loop and other is the while loop, and the for loop just iterates over all the elements starting from the index 1 because the zeroth index has no predecessor, and we check whether the index is greater than 0 or not, and if the array element at the jth index is greater than the key or not. Here key will be the present index. Okay, so if it is, then we will just like shift or rotate the elements, and we'll just put at the key at the j plus 1th position. Okay, so it actually works in order of n square, and it takes auxiliary space order of constant, that is order of 1, and it takes maximum time to sort if elements are sorted in reverse order, but takes minimum time, that is order of n, when elements are already sorted. Okay, so it is an incremental approach because we increment through the indexes and check the predecessors. Okay, and it is an in place sorting algorithm, that is we do not require any extra temporary array, and it is a stable algorithm, which means that we the like let's say there are two elements that are of same that are equal, let's say 11 and 11 in this array. So whenever we um, sort this array, then the first 11 will be always be before the next 11 which is in the array. Okay, so this is the meaning of stable thing, and the online means that it can actually sort the elements in the runtime. Okay, so that's why it's called, also it is one of the online algorithms as well, and it is used whenever number of elements are small. Okay, and it is also used when the elements are almost sorted because only few elements are misplaced in complete big array, so we can use it. Okay, so now we can actually somewhat optimize this. So here comes the binary insertion sort. So in the binary search, like the position, finding the position where to insert the correct element can be searched through binary search method. Okay, and this binary search has been discussed by me in my previous videos, so you can click on the I button and go through this video, so you will understand what binary search is. Now this can the binary search can actually reduce the insertion from order of I to order of log I, and but still the like it in the in the worst case we can reduce it, but still it will actually run in order of n square only because see, the position finding can be done in order of log I time, but when we actually rotate the array, then it will always take order of n. So as a whole, total order of n square will be there. So now you can also see that how insertion sorts for linked list can be implemented. So in here we just need to follow these three steps. So first is that create an empty sorted or result list, then traverse the given list for every node, do this one, and what we have to do for every node is that insert current node in the sorted way in sorted or the result list, and at last change the head of the given linked list to the head of the sorted list. So like this we can actually sort the linked list, but still we have to take this extra space in the memory to create this temporary list. So we have to keep that in mind as well. And if you want to know more about the stability in the sorting algorithms, then you can check this article as well. This basically tells what I somewhat explained in brief. So if you want, you can check this as well. But yeah, that's nothing more in it. Still, it's up to you. And till the next video, keep watching and keep learning.